In this video, we're going to go over how to find an absolute maximum or an absolute minimum of a function on an interval. Now, Fermat's theorem tells us that the only place where you can have maxima or minima, or the general term is extrema, is either at the endpoints or at critical points. Critical points are where the derivative is either zero or doesn't exist. And some people call critical points critical numbers. It means the same thing. Okay. So our recipe is pretty simple. First thing is we have to find the critical points. Second thing is we have to find the endpoints. That part's pretty easy. Then we just compare the values, and the biggest one wins. And the point is, there are very few candidates for where the maximum can be. You just list all the candidates and compare them. The biggest one wins if you're looking for a maximum. The smallest one wins if you're looking for a minimum. So let's work an example. So we're going to look for maxima and minimum values of the function 10x over x squared plus 1. So we're going to do this on the interval from 0 to 3. Now, between 0 and 3, this function is continuous. Since it's continuous on a closed interval, it has a maximum value, it has a minimum value. That's the extreme value theorem. So we have to find the critical points. Well, that's where the derivative either doesn't exist or is 0. Now, this is a perfectly good function. The quotient rule will give us a derivative, so the derivative always exists. So it basically boils down to finding out where the derivative is 0. So let's take the derivative. The derivative of a quotient is the bottom times the derivative of the top minus the top times the derivative of the bottom, all divided by the bottom squared. And the derivative of 10x is 10. The derivative of x squared plus 1 is 2x. And you multiply it all out, and you get 10 minus 10x squared over x squared plus 1 squared, or 10 times 1 minus x squared over x squared plus 1. So where is that 0? Well, the only place that a ratio can be 0 is that the numerator is 0. So this function is 0, the derivative is 0 exactly when 1 minus x squared is 0. So the derivative always exists. It equals 0 at x equals plus or minus 1. So plus and minus 1 are our critical numbers, or our critical points. Except they don't both count. One of them is in the interval. 1 is between 0 and 3, but negative 1 isn't. The only critical point that's actually in our interval is x equals 1. We don't care about x equals minus 1. It's not in the interval. Find the endpoints? Well, that's pretty easy. And then we just make a table. The only candidates for maximum and minimum are the endpoints 0 and 3 and the critical number 1. And now you look at these and say, which is the biggest of 0, 5, and 3? Well, 5 is the biggest. 0 is the smallest. And we're done. The maximum value of the function is 5. Where does the function hit that maximum value? It hits the maximum value at x equals 1. Now there's sometimes some confusion in the terminology. When people say, where's the maximum? People might say, oh, the maximum is 1 or the maximum is 5. Be careful about this. The maximum value of the function is 5. It happens at x equals 1. And the minimum value is 0, and it happens at x equals 0. Okay, one more example. And this example involves logs. So we want to find the maximum and the minimum values of x natural log of x on the interval from 1 to 3. So step 1, we find the critical points. We want to take the derivative and set it equal to 0. The derivative, we use the product rule. And you get natural log of x plus 1. So where is that 0? Well, let's see. If 0 is the natural log of x plus 1, then the natural log of x must be negative 1. So x must be e to the negative 1, in other words, 1 over e. But that isn't in the interval. 1 over e is less than 1. So in fact, there are no critical points in the interval. So the only candidates are our endpoints. We compare our values and we say, hey, at one endpoint the value is 0. At the other endpoint the value is 3 log 3. The minimum value is 0 and it occurs at x equals 1. The maximum value is 3 log 3 and that occurs at x equals 3. And that's it.